Good morning, Devox. It's nice to see you all in the room for this last day, one of the last conference and the last talk. It's the third time in a row I'm coming to Devox to talk about CDI II. It was the road to CDI II. CDI II is coming, and now we are in the third final season. The CDI II is upon us announcement. So I'm Antoine Sabot-Durand. I'm working at Red Hat. The spec lead of the CDI II specification. I try to work on CDI to make it better known, and you can follow me on Twitter, or you can follow the Twitter account for the CDI spec. Before we start, how many of you are using CDI? Wow. CDI 1.2? Okay, great. And how many of you are finishing their night here? Okay. And last question: how many of you read the spec? Okay, that's better. You should read the spec. It's not all the spec, but you can grab a few things around.
Very readable.
Yeah, it's very readable. Thank you. Not all the part, but let's say 90%. We are trying to make it clearer and clearer. So, what is the topic of this morning? So, I'll start with the fast flashback on CDI and the CDI II status right now, and we will enter in the important stuff, reviewing a few major features that we add to CDI II. So, mainly the Java SE support and other things. You will see that. And after that, if you have a question and if you want to discuss about the next step after the CDI II, I'll be glad to talk with you and answer your question. So, previously on CDI. So it's a rather young specification. It started in 2009 with the Java EE 6 release. And we should release the CDI II in about 2 months, in January. So we have three major releases in not a very long time, only 8 years, less than 8 years, let's say 6 years. So it's moving quite a lot, and it's one of the major specifications across Java EE for the adoption and for the feedback we have, and thank you for the feedback on the specification. So to go back on the feature of CDI, so CDI is for context and dependency injection. So we are talking about dependency injection, lifecycle management for a component, and another thing that is not in the name of the spec is it's the portable extension feature. That is probably one of the most important features in the spec, and it's a pity that we don't have put something in the name to tell that it's a way to enhance the Java EE platform and to integrate a third-party framework or overspec in the CDI programming model. So to go fast through the feature, so as I said, we have lifecycle for object. We can add new context, so new lifecycles for the object. All the dependency injection feature is type safe, so it's only based on types. You can select the component at development time or at runtime. We have also all the features for AOP with interceptors and decorators. And there's also a nice feature that a lot of people are giving us nice feedback. It's the event bus and the event notification model we have in CDI. And as I said, all the SPI of the spec that allow extension of the platform, of the CDI and the Java EE platform, because most of the Java EE specification today is using CDI. Okay, so after this first release, there was another smaller release, of course, that came with the Java EE 7. So the first was CDI 1.1. In CDI 1.1, we add feature like automatic enablement of CDI. So in Java EE 7, you have CDI out of the box without adding anything. We add a lot of stuff for introspection, so you have more information about metadata, about bin, about interceptor, etc. We also eased the tools to access CDI from outside CDI. We also add a feature to enable interceptor and decorators through the @priority annotation, and also provide tools to use non-CDI class unmanaged instance and provide CDI service on them. I will go through the CDI 1.2. It's more clarification stuff, etc. So the status of the spec. So we started in September 2014. Wow, more than two years ago. We released 2 early drafts, one in the summer of 2015 and one this summer. Right now, you have the last alpha version of Weld, which is the reference implementation of CDI. So it's the Weld 3 Alpha 17, so you can grab it, play with it, give your feedback. Most of the features I'll show you today are in this alpha, and there will be probably a new alpha in the coming weeks with new feature in it. So I will tell you when the features are available to play in implementation yet, or if you have to wait to have it. So if everybody goes well, we should be able to release in January. So let's say end of January. We are still working on the last feature right now. So we have a feature freeze at the end of the month. After that, we have the polishing, the work on the TCK, on the implementation, etc. And we will still doing some stuff in the spec regarding clarification and things that don't have impact on implementation or TCK. If you want to have further information on CDI, the cdispec.org website is here for you. So you have a lot of resources on this website, which should be updated more frequently, but will be after the release, I think. I hope. The things that could be interesting, you have information regarding framework using CDI. So you have this in the resource CDI, part of the site. You also have training stuff on CDI, so some presentation, some talk, some slides, so you can grab them and so go to the site and check and give your feedback. And of course, you have the blog post as well. So that's all for the flashback. Let's talk about the new features. So probably the most awaited or the most asked feature for CDI is probably the Java SE support. So until now, CDI is only working in a Java EE environment. But this question of having the Java SE support came in the very early stage of the CDI life, and there was many solutions for that. So there was solution at implementation level. So if you take Weld, if you take Open Web Beans, they have their own solution to bootstrap a CDI container in Java SE. And you have also the Delta Spike project that provide an abstract way to do that. So why is it important to have it in the spec? It is important to have it in the spec because we are working with a lot of other spec that support Java SE. And they said, well, okay, CDI is nice, but when I'm providing, as I'm providing Java SE support, when our users are on Java SE, they can't use CDI because it's not supported at the spec level. So it's a way to bootstrap the adoption of CDI, mainly. And also, if we go on Java SE, third-party framework will probably be more ready to develop extension for CDI and add the support. So for those who read the spec, you remember that there are a lot of intrication, a lot of content, Java EE content in the spec. So there are a lot of mention of AGB specification, servlet specification, a bit of transaction and interceptor specification, etc. So it was a long work to prepare this Java SE support. So the first was not very fancy, but important. It was to work on the spec. So the CDI 1.2 specification was a monolithic stuff. We have to modularize it. So we create a CDI core part, and we create a CDI for Java EE part. So now, if you go to the cdispec.org website and download the spec or read the spec, you will see that there are three main parts in the spec. So one for the core, which is all the features that are common to SE and EE, and the EE part. And of course, between them, the SE part. So that was a long work, even if the result is not very spectacular. It was necessary to be sure that we provide something nice for the spec. We couldn't do like other spec are doing, like if the container is running under Java SE, then blah 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 blah, because there was AGB everywhere, and we have to cut all the parts to be sure that we don't forget anything. And for the TCK as well, it was important to do that. So, to do that. So we added an API to support bootstrapping in Java SE. So this API will be available for Java SE and won't be available in Java EE. So we'll probably provide a different set of API for EE and SE with a superset for SE. It's not yet decided, but it's probably what we are going to do. So we have the SE container initializer here. We ask a new instance with a static method. We have a builder pattern to configure the container. So here we disable discovery. So we avoid having all the class in the class path discovered by CDI. And we add the class that we want discovered has been during this configuration phase. There are a lot of other stuff you can add. You can add interceptor. We probably in the future add a programmatic way to define extension. So it's a very complete API. You should check it in the Java doc. And when you have finished your configuration, you call the initialized method, and it returns you the container, an SE container. The good news is that the SE container is implementing the instance interface. So you have direct access to the bin graph. So you can do a select with the type, with the qualifiers, and get instance for a bin. Like it's done here. You see that we are doing a select on my service class. So here I get something like an instance in CDI. So you can check for ambiguous resolution, for conflict, etc. Here in my example, I don't do that, but I can do that. And with the get, I get the instance. When I've finished, I close the container, but you are not, it's not a mandatory part because the container implements the auto-closable interface, so it will be closed automatically at the end of your code. Regarding the support of multiple container, it's not forbidden, but it's not a portable feature. There are discussions between implementation, but in Weld you will be able to have multiple container in your application if you want to do that. One of the problems we have with the SE support is the context we have in CDI. So in CDI we have a bunch of built-in context. You can add your own context, but we provide context for application, for request, for session, for conversation. And of course, when you are under Java SE, those contexts, most of these contexts are not available. Session context doesn't have really a sense, a meaning in Java SE. So regarding the context, application context is there. It's obvious. So you have an application context, and the life cycle of the Dean application context will run from the bootstrapping of the container until it's shut down. We had a discussion around supporting other context. Right now, what we plan for CDI II, what we done for CDI II, is to support the request context. So to support this request context, we added a way to control the activation and deactivation of this context. It's done through an API using a request context controller, as you can see there. So we have a built-in bin allowing you to decide when you activate the request context and when you deactivate it. So it allows you to do that manually, programmatically in your code. And you can also do that through an interceptor. So here we are activating the context only for the invocation of this method here. So you'll be able, the reason why we've done that, you'll be able to use third-party libraries defining request scope bin in Java SE. But session scoped bin and others won't be available because it's right now it's not easy to find a common ground for the usage of the session in Java SE. So we plan to introduce things later in a new version of CDI, but right now we are supporting request context in your Java SE application. And if you need something else, you can still create your own context for Java SE. There's no problem. Okay, another list of features that we worked on is the eventing system in CDI. So it's, as I said in the introduction, it's a very popular feature in CDI. It took a long time to discuss around the enhancing event and add the feature in the event. And the main feature we introduced were the event ordering. So now in CDI II we'll be able to give a priority on your observers, decide which observers is called first and last. And last but not least, we are introducing asynchronous events, which is a feature that was requested by a lot of users for a long time. So let's start with the easiest part. So events ordering. So events ordering are done on the observer side, so you are ordering observers. We are using the @priority annotation, so coming from commands annotation. So we had to ask for a revision of the commands annotation specification since the @priority wasn't targeted to parameters. So we have to ask for a chance for that. So it's done now, so it will be available for CDI II. So the lowest value is first. So if you have a priority of 0, it's coming the first observer being called. And if you don't provide the @priority value or provide the @priority annotation on your observer, you will have a middle range priority. So there is a middle range value by default, allowing you to define observers triggered first and observers triggered last, and observer, I don't mind when they are triggers, but they won't be first and last. That's the idea behind that. And yeah, after a lot of discussion, there won't be any priority on asynchronous event in CDI 2 at least. So what does it look like? Looks like this. So you define your observer. You add the add priority annotation on your observer, and you define the order of the call like this. The good news is if you are creating portable extension, you know that portable extensions are based on the eventing system of CDI, so you have observers in the portable extension to observe the lifecycle event triggered by the container at boot time. So you can also have this prioritization done in your portable extension, so to be sure that a process annotated type of a given extension is launched first and another one is launched last, etc. Could be interesting and could bring new usage, I think, in developing extension and in the ecosystem as well. So the other feature we added for the event in CDI 2 is the asynchronous event. So there was a lot of discussion. I won't go through all the discussion we had on asynchronous event. But as you know, when you are working on a Java EE spec, you have certain constraints. And one of the constraints is the backward compatibility. You cannot introduce things that breaks existing codes. So that's the center of the discussion here. If you read the current chapter on event in CDI 1 specification, it's not really specified that the events are synchronous. It was a decision taken by implementers, so today it's something that we have to take into account. We have synchronous event in CDI 1. We also have usage that were taken by users and that were allowed by implementation, is the fact that the payload that is used in event can be muted. So you can observe an object and change the content of the object. Okay, so I already said that. It's double. And yeah, and the conclusion of that is with all these constraints and with all this usage we have, we cannot go on an async event system blindly. So if to go back to the firing pattern today, we have something like that. So we inject the event with the payload and we call the fire. And on the other end, we have an observer observing the payload and doing things, can change the payload if he wants. Okay, so, and when I have a bunch of observers, they are called in the same thread than the firing thread, and they are called in no particular order. Okay. So, asynchronous event can't mute payload, because if you mute payload, you have to lock to wait for other observers, asynchronous observers, to do their job. They can't access CDI context states at the starting point, because as they will be asynchronous, they will be running in another threads. And if you read the spec, you know that CDI context, CDI built-in context are not propagated across thread. No context is propagated. The application context is shared, so it's accessible. But for other contexts like request, session, and conversation, you don't have access to them. And it cannot be transactional for the same reason. And if we want to provide a convenient and fast way of executing this asynchronous observer, we won't be able to provide the transactional support we have in synchronous event today. So, to sum up, with all these constraints, you take the constraints from the synchronous event and the constraints we decided on the asynchronous event. If we want to be backward compatibility, all the synchronous events today should remain synchronous. If we want to go async, we should decide it on the firing side. But if you want to go async, you should also decide it on the observing side. Why that? Because you have libraries that are firing event, and they are not listening this event. They are assuming that users of this library will observe the event in their code, and vice versa. They are libraries observing certain kinds of a system event, for instance. You can observe the fact that context was started, and they don't fire this event. So you have consumer and producer alone, and they assume today that they are working in the same thread. They can inject instance in a certain context, etc. So you cannot decide to go async only on one side. You have to decide it on both sides. So, conclusion of that. We have to use a new method to trigger the event. So we introduce the fire async method to trigger the event asynchronously. And we had to introduce a new observer, the observes async, which observes asynchronous event. So to summarize that in a sum up, so you have the old way of doing things synchronously with the @observes. So it will be triggered by event fire, and you have the new way of defining an observer with the observes async, and it will be called by the fire async method. And as you see, there was a lot of discussion. We don't have a synchronous call do here. So if you fire async an event, it won't trigger the synchronous observer. It's a decision we took to avoid confusion. Another nice stuff we added to asynchronous event is the fact that you can provide your own executor service to the observer. So you can have your executor here and provide, in fact, the rules of the thread in which you want to have the observer called. So you can do something like that, for instance. You can say, okay, this event is related to the UI, so I want this observer to be, so I want the observers of this event be called in the UI thread. Or you can have your own executor service, of course. Another question we had regarding synchronous event was the exception handling. That's why we based all the asynchronous stuff, all the asynchronous events in CDI II on the new completion stage API in Java 8. So when you call the fire async method, you get a completion stage of the type of the payload you are using in your fire. So the completion stage allows us to have all the features that Java 8 provides for exception handling for asynchronous operation. In the events today, in synchronous events today, if you have an exception, the event chain is broken, the observer chain is broken. The observer that throws the exception stops the invocation of other observers. So what we need in CDI II, we cannot do that, of course, and we need to get all the exceptions that may occur in the observers, the asynchronous observers. So you'll have all the information of the exception in the completion sense. That's not a CDI II feature, that's a Java 8 feature. You will have all the information on the exception that happens in your asynchronous observer notification in the completion exception. So it will be listed as suppressed exception in this exception. So you will have a list of all the exceptions that occur during the async observer called. So you will have the free solution to handle your exception. You can get the completion stage returned by a fire async. You can use the when complete to deal either with the results or the exception regarding what you are doing. You can do the handle. It's quite the same, but the big difference is that it allows you to transform the stage and to say, okay, there was an exception, but I'm doing something else. I want to transform the stage as it's done. Or you can go for an exceptionally, and you are only treating the exception at the end, and you treat only this exception case and not a success. So all of this is not CDI specific. It's coming in Java 8, and it's the API we have in the new completion stage, and perhaps completion compatible feature. You may be more familiar with compatible feature API. Another point I wanted to discuss with you regarding a new feature in CDI is the SPI enhancement. So we have a very nice SPI in CDI, allowing us to provide a portable extension and to have a better integration tool for third-party framework on other spec. The first feature I wanted to show you, it's not the revolution, but it's very convenient. In CDI, we are using a lot of annotation. If you are developing in CDI and doing a few advanced stuff, you need, from time to time, to have annotation instance. You don't have an easy way in Java to have annotation instance. So, from CDI 1, we provided the annotation literal to help you to create instances. So, for instance, if you want to create an instance of the application scope annotation, you're doing something like that. So you use the annotation literal to get that. It's not very intuitive, but it stays rather simple to use. But if your annotation has members, for instance, if you need to create an instance of the @named annotation, you have to create your own class like this. So you have to create a named literal class. You have to extend the annotation literal. And we have to implement the named. Here, named is the annotation, @named. And you have the member, which is the value. You need a constructor to initialize the member and method to return the value. So it's quite cumbersome only to have an instance of an annotation. So in CDI 2, we've provided helpers out of the box. So these helpers were available in third-party solutions like Delta Spike or others, or you can have your own libraries. Right now, it will be in the spec, in the API. So it doesn't change a lot for the annotation without members. So you have a static field in the annotation, allowing you to get an instance. But if you have members, it will change a lot, as you see. Having an instance of named will be done with that. Name literal off, and I give the name here. So it will make some less code in your application. Okay, another feature I want to focus on and is also important for portable extension developer is all the metadata helpers that we added to CDI 2. How many of you are developing portable extensions here? Wow, not a lot. Well, so when you develop portable extension, at some point you need to create metadata. You need to create annotated type. You need to create new type of bin. You need to create producer, etc. And injection point. And it's not very, it's a bit cumbersome to do that. It's not hard, but you have to implement an interface and do a lot of boilerplate code to do that. So let's take an example. In CDI 1.2, let's suppose that I have a kind of legacy framework, and I want to adapt this framework to CDI. In this framework, I have an annotation, proprietary annotation, called add_cache_context, and it can be applied on field on my class. What I want to do with this CDI integration, I want to transform the field with the add_cache_context annotation in injection point. So put @inject on them. So as I said in the last bullet, it's quite easy on the paper. I'll use an extension. I will process all the annotated type with the add_cache_context in them, and I will replace the @cache_context by @inject. If I have to do that in CDI 1.2, first I need to implement the annotated type that will be used to decorate the original one. So you are doing that by decorating an annotated type. So I create my annotated type. I call it the auto-inject annotated type, and it takes, let me see, it takes the original annotated type here and will use it for defaulting most of the method. But I have to override some of the methods. And the methods I want to override is the list of the annotated fields that this annotated type will return, because I want the annotated fields to be changed for the fields that have the @cache_context annotation. Still following? So here in my constructor, I'm creating this list, if you see. So I'm getting the fields of the delegate, and I'm testing if there is an cache context. Yeah, if there is an cache context annotation, so I don't add the field I found. I decorate the field with a new class, auto-injecting annotated fields of fields. Okay. If there is no cache context, I use the original field. So I'm creating the set of fields and overriding it like this. So it's not very complicated, but not very readable and very boilerplate code. So after that, it's more similar methods doing, in fact, delegate of the method. And after that, I have to create my annotated field class. So this annotated field class will do the same for annotated field. So I will have the delegate field in the constructor. I will get all the annotation of the constructor and will add the inject annotation to the bunch of annotation on the field. Still following? Okay. And now, that's quite, so I have all the method that testing if the annotation is present. So I have to test, okay, if I'm asking for annotation, I have to say it's there for the inject annotation. And last but not least, when I have developed both classes, I have to use those in an extension. So I have the auto-inject extension that is observing the process annotated type event. And in this process annotated type event, I'm catching only the class having the cache context annotation. It's the with annotations, meta annotations that allow me to do that. So I catch only the type having the cache context extension. And for those type, I'm changing the annotated type like this. So the extension is quite rather simple, but the class I have to create to do that, a rather simple feature, are very verbose. So in CDI 2, we introduce configurator helpers for much of these metadata, so annotated type, injection point, bin attributes, bin, and observer method, if I don't miss something. And you can access those configurators in the lifecycle events of your container. So it allows you to build those metadata at the end of the event invocation. So if we take the example before, all the slides you saw previously are done here in one slide. So we still have the extension. In the process annotated type event, we ask for a configure annotated type. So we have a configurator returned. We can use the filter fields that return a stream. We can find the field that have the cache context, all the fields that have the cache context annotation. And for them, we are adding the @inject annotation. And that's it. So it's not a revolution as well, but it will help a lot of people to develop their extension because right now it's not hard, but it's a bit cumbersome, and there are a lot of code to produce to provide quite a basic feature. So we hope that it will help boosting the adoption of the portable extension stuff in CDI. And I hope that next year when I'll go back for CDI 2.1, the road to CDI 2.1, or perhaps CDI 2.1 is upon us if Java E8 is released next year. I'll have a bunch of hands raised when I ask who is developing portable extension. Okay, let's finish with AOP enhancement. So the feature I'm going to show you is not completely finished, but it's finished at around 90%. So we're still in discussion, but the pull request is there, and we are discussing on the content, the name, etc. And the part of the team working on the implementation are already testing stuff. And they pass from the step saying it's useless to do that, we don't need that because it's too complicated, to the step, okay, it's useful, we are trying to implement it. So right now, in CDI, for those not very familiar with CDI, you define your bins in two main ways from the developer point of view. You define it from a class, so create a class. You add an injection point with the @inject annotation on fields or methods, and you can add application context. You can add a context on the class, etc. So you define the bin like this. And there is another way to define the bin. It's through a producer. So the producer is declared with the @produces annotation, and you can apply the @produces annotation on a field in an existing bin or in a method on an existing bin. But right now, when you define a producer, the produced bin won't be eligible to have interceptor activated on it. So for instance, here I'm creating a bin of type myService. There is no easy way, there is no out-of-the-box way to make all the method or some method of the myService instance that will be produced transactional. So if I do that, if I write @produces @transactional and produce service returning myService, it won't be the myService object return that will be transactional. It will only be the method produce service that will be called transactionally. So we don't have a way to say, okay, the produce instance will be transactional. So we try to figure out a solution to provide this feature in a more abstract approach to be usable in other use case. So we are introducing a new SPI interface called Interception Factory. So the Interception Factory will allow you to take an instance that is not managed, what is not managed and not created by the container, and apply all the feature or service from the container on this instance. So for instance, the interceptor. That's the first point here. We want to have the interceptor. So you can use it in the producer, or you can use it on a custom bin. So if I take my previous example, I want to apply, how to say? I want to apply a transactional annotation, on one of the methods of my produced bin. I can use the interception factory. So the interception factory will be provided as a built-in bin, so you be able to inject it in your producer, like it is done here. You have the interception factory injected in your producer. And the interception factory provide as well the possibility to configure the underlying type, the annotation on the type, through an annotated type configurator. So I'm doing quite the same I done in my previous example with you remember replacing the @cache context by @inject. But here I'm taking the class, I'm choosing some method on the class, and I say, okay, this method I add the @transactional annotation, and I'm taking that and I'm giving this to the container with the create intercepted instance, and it will use the annotation I define in the annotated type to apply the interceptor binding on this method. So here I have a method called do something. Sorry, I have to show on the screen with my pointer. I find this method. On this method, I add the transactional annotation. And the result here, I'm returning an instance that will use this annotated type, and it will be an instance of the my class object. But there will be a transaction activated only on the do something method. I can have done a simpler example, applying the transactional on all the class and having all the method transactional. But it's to show you the fine-grained solution I have here to do that. So you can do this for a producer, or you can do this when you create a custom bin and you define the create method in the custom bin to create the instance of your bin. And I think I'm finished. I have some time left for question. So you can still give feedback for CDI, grab the implementation, test it, send a question, ask for clarification. You can ask us on the IRC channel or mailing list. Go to the website, of course, follow the Twitter. And if you have questions, I'm here to answer. So it's perfect.